Welcome to the first lecture on Spatial Modeler. The title of this lecture is Introduction to Spatial Modeler. In this lecture, we tackle the following inquiries. What is Spatial Modeler? Why is Spatial Modeler considered as a simple method for creating programs? When is Spatial Modeler needed? How are models designed to solve problems we face? A practical example of designing a model. We start with the first inquiry, which is, what is Spatial Modeler? Spatial Modeler. It is a fast and simple way of satellite images programming and analysis. It is an easy method of creating computer programs in which their inputs are data layers such as raster and vector files, and their outputs are new data layers which include new and very important information that has been calculated and discovered by the created program. For example, in this lecture we will create a simple program for correcting the elevations values in a digital elevation model, and in the following lectures and courses we will create complete programs or models for several projects in many fields such as surveying, agriculture, tourism, construction, land study, 3D vision, image enhancement, and others. Now we move to the second inquiry. Why is Spatial Modeler considered as a simple method of creating programs? Spatial Modeler is considered as a simple method of programming, since programming in various programming languages is usually in the form of written codes. These codes may fill thousands of lines in some cases, and it takes long programming time that could reach several days or months. However, in the case of Spatial Modeler, another type of programming is used, and it is called block programming. It simply depends on drawing a group of blocks and connecting them to each other instead of writing a programming code. However, it sometimes needs writing a very little amount of codes. This programming method, which is going to be explained in this course, simplifies the process of programming significantly and speeds it up, as creating a program may only take a few minutes. Additionally, Spatial Modeler includes libraries that contain a huge number of mathematical equations used in data analysis and solving multiple problems that may face satellite images users. Programs created by Spatial Modeler are called models. Now we move to the third inquiry. When is Spatial Modeler needed? We need Spatial Modeler when the work requires creating a new information layer which represents a special request or a customized solution. This layer cannot be created through the tools available in Erdas Imagine menus. Actually, it requires creating a special program or model to produce such a layer. Now we move to the fourth inquiry. How are models designed to solve problems we face? Usually, there are three fixed steps for solving problems or establishing customized solutions that require creating any model. The first step is determining what the problem really is, thinking of how to fix it, and searching for the mathematical equation or operator that enables us to solve this problem. Note: A, B, or C are just symbols that could be raster, vector, DEM, scalar, which is a digit, or other things such as a table or a matrix, and these things are going to be discussed later. The second step is studying the equation or operator with the goal of determining the necessary inputs and their types such as raster or vector. The third step is to test the equation one more time with the aim of determining what the outputs are and what their types are, such as raster or vector also. Now, after knowing the inputs, outputs, and process, we may create the model by drawing it in the Spatial Modeler editor. Now we move to the fifth and last inquiry, and that is a practical example of designing a model. The following example shows a problem with a file, and we will demonstrate how to create a customized solution to solve this problem by applying what was previously mentioned in a practical manner. Assuming that we have a DEM that represents elevation of Earth's surface at a certain area. In this DEM, there is a fixed error of -15 meters in elevations in all pixels. We need to fix this error by creating a model that is able to fix the problem. The first step is determining the problem, thinking of how to fix it, and searching for the mathematical equation that enables us to solve it. Also determining the type of operator being executed in the equation, and the equation is corrected DEM equals incorrect DEM plus 15 meters. And the operator here is addition. The second step is to study the equation in order to determine the necessary inputs and their types, whether raster or vector. In this case, the inputs are the incorrect digital elevation model and the number 15, and their types are raster and a scalar. The third step is studying the equation one more time with the aim of determining the outputs and their types, whether raster or vector. In our case, the output is the correct digital elevation model and its type is raster. Now we move to drawing the model. Open the digital elevation model that includes the error percentage required to be corrected in order to conduct a comparison in the end. Open the image lendem.img. Then open its metadata. Then open the Pixel Data tab and save it. Now close the view. And from Toolbox, select Spatial Modeler Editor. So the Spatial Modeler Editor appears, which is used to create models. And based on the previous steps that we performed, the first input is a raster image. In here we write the word raster, and we will find raster input, which we will drag into the Spatial Modeler Editor. The second input is an integer that is represented here by the word scalar. So we search here for the word scalar, we will find scalar input, which we will drag into the Spatial Model Editor as well. As for the output, it is a raster image too. We search for the word output, and then we select raster output. Then we drag it into the editor pane. It is worthy to notice that all we select from inputs and outputs are called objects. As for the process we mentioned earlier, which is addition, it is called operator. We search for the word add, which can be found in the math library. So we drag it and place it between the inputs and outputs like that. We draw the connections by clicking on this part and dragging it till it is connected to this part of the other block. One more time, just like that, and from here too. Now the equation is complete, and the model also is complete, but we have not defined the input or the output yet. But if we click Run to execute the model in this condition, the program will actually execute the operation. However, it will ask us to enter the names of the input image and the output image. Also, it doesn't ask for the integer because it takes a default value that equals 0. Finally, click Close. And to avoid this, we define all the inputs and outputs first. So we double-click on raster input. We select Lendem from the examples folder, like this. And click OK. First double-click on Scalar and write 15 instead of 0. Then select Integer, because it does not contain fractions. Finally, click OK. And also in the output, press double-click, select the name and directory of the resulted image, for example, output-correct-dem, and click OK. Click Run, and let the program take its time to execute the operation. Do an undock, then minimize this window, so we may get back to it later. From Home tab, add 2D View. And open the image that resulted from the model. Also, open its metadata and the Pixel Data tab. And to test the accuracy of the results, we compare the DN values in a group of random pixels like 0 and 0, 1 and 1, and 3 and 3, to the equivalent ones in the wrong digital elevation model. We will find that there is a difference of 15 meters, which is the number we added. So we understand that the model is successfully accomplished. Close the metadata and the view. Then we get the Spatial Modeler back one more time to get to know its important contents, which are Spatial Modeler Workspace. It's the shape in front of us with all what it contains. Spatial Modeler tab. It is located in the ribbon, and it appears when opening the Spatial Modeler. Spatial Modeler Editor. It is the part in which we draw the model. Operators. It is the part that contains names of libraries that contain the mathematical equations. To save the model we created, select Save As from the File menu, then Spatial Modeler As. Then name it as correct-dem, for example. Then save it with the extension gmdx. Open it again. Select Open. Then select the model. Note: we created the model and explained the contents of the Spatial Modeler in a brief, quick way and without getting into the properties and the modifications of the model contents. We will tackle many of these properties in later lectures. By that, we came to the end of our lecture, and we have got acquainted with the meaning of a spatial modeler and how to use it. We also built a real model and validated its accuracy. Thank you for your undivided attention.